and share screen. Okay, today we're going to finish this chapter on production costs and output, okay? There are two kinds of costs in the short run. In the short run, at least one input is fixed. You cannot change that quantity. Most of the time we think capital, like machinery, buildings, experiment stations, etc. These are considered a capital equipment, capital input, okay? And they tend to be fixed input in the short run. The rent has been paid. There's nothing you can do about it by changing the output level. Okay, so generally capital and land, etc. are considered fixed inputs. Some are variable inputs, like ingredient inputs. If you want to make potato chips, you have to buy potatoes from potato farmers, I guess. Those are variable inputs. Likewise, labor. Laborers, usually we think labor is a variable input. You can give them a notice that they won't be needed next Monday. We will call you if we need them, and they never hear anything from the boss. Things like that. Okay, so some variable inputs. So the fixed input is the cost of rental cost of renting buildings, land, etc. For farmers, you need to plant corn or soybeans. Sometimes the land you have is not big enough. You may want to rent farmlands from other neighboring landowners. So in that case, you have to pay rent, so many dollars per year, etc. These are fixed input. And buildings, rental costs, you sign a contract to rent for how long, 1 year, 2 years, whatever. Those have to be paid regardless, okay? So these are fixed costs, and by definition, it does not change. So as output increases, you can see fixed cost does not change. It's constant. Variable costs, usually in the United States, that would be the cost of labor. You cannot do very much. A single person cannot do very much. So if you want to increase output, you have to hire a bunch of people, a bunch of workers. Some are skilled workers, others are unskilled workers. Still others are semi-skilled workers, etc. You have to pay them wages, okay? And you can control the quantity or the number of these workers, and they're called variable costs. As output increases, you need more of these, you need to hire more of these workers, and production cost rises. And that part of costs that rise with output are called variable costs, okay? So as in this table, you see as output increases, production cost, variable cost increases. It always increases output. It is variable, but we know which way it varies. It always goes up, okay? So here is a typical discrete case. Variable cost is rising, okay? In the discrete case, it's not easy to detect its general shape. I will show you the very continuous case later. At any rate, variable costs are rising as output increases, but eventually you hit a wall. Okay, you hit a wall, and no matter how much, I'm not drawing a good wall here, but let me try this again. You hit a wall, and beyond that, no matter how much you spend your money, you cannot increase output. That's sometimes called capacity of that fixed input, okay? So adding the fixed cost and the variable cost, you get total cost. So this includes the cost of capital input and the cost of laborers and other ingredient inputs. We will ignore ingredient inputs, okay? Because you cannot change very much. If you want to produce potato chips, you have to have so many potatoes. There is nothing you can do about it. Okay, so combining these two, fixed costs and variable costs, you get total cost. Okay, it always goes up as output increases. So here's the variable cost, and here is the constant or fixed cost. And if you add these two vertically, then total cost function is simply a shift of variable cost. Okay, it's a vertical shift by the amount of fixed cost, $100, okay? Because rent has to be paid no matter what. So that's the discrete case. That means outputs cannot be fine-tuned, and output can be adjusted in chunks, okay? Like in quantum mechanics, energy can be converted into masses, but this transformation curve is not smooth, but they come in chunks. So what is the meaning of marginal cost? By now, I think you get the idea because we have studied marginal utility and consumer demand theory. So marginal cost is the change in total cost attributable to a small change in output. So that marginal cost is defined, this triple bar means defined as, quote unquote, change in total cost divided by a small change in output, delta Q, okay? So obviously, fixed cost does not change, so this is also equal to change in total variable cost or small change in output, okay? So how do you get marginal cost? Output is increasing on the first column and total cost is increasing. So how do we get marginal cost? Well, from when output doubles from 5 to 10 units, total cost increased from $125 to about $140. So this difference is about $27 divided by change in output, which is 5. So that's roughly about $4, okay? That's how you get marginal cost. So that will be the general shape of the marginal cost curve. In the discrete case, it's not easy to detect its general shape, that it is U-shaped. It's not easy to verify this in numerical examples. Later, I will show you the continuous case and it will be crystal clear. And increasing marginal cost comes from diminishing marginal product. I will explain that a little later. So there's another concept, average cost. That's total cost divided by the level of output. So as output increases, total cost rises. So total cost divided by the levels of output. In the first column, we cannot divide a number by 0, so this is not defined. And then total cost divided by output 5, well, that would be 25. $142 divided by 10 would be $14.03, 30 cents, and so on, okay? Next, we will switch to the continuous case. Total cost, again, is the sum of fixed cost and variable cost, okay? So here's the definition again. Total cost is fixed cost plus variable cost. Total cost curve is always positively sloped. It does not go down. It always goes up with output. But the general shape of cost function for most products is known. As output increases, total cost increases at a decreasing rate at first, but beyond a certain point, we call it inflection point, the curvature changes from concave shape to a convex shape like that. Okay, that point is called the inflection point. And total cost rises at an increasing rate beyond a certain point. So this is the general shape for most products. We are measuring output, firm output Q on the horizontal axis and total cost on the vertical axis. It begins at this vertical intercept. This is called the fixed cost. Oops, red on red doesn't show. So here is the fixed cost. And as output increases, this total cost function, total cost curve is always positively sloped, okay? It increases at a decreasing rate at first, but beyond a certain point right there, it's called the inflection point. Curvature changes all of a sudden. A lot of young people ride skateboards, you know, they have some curves like this. Eventually, the cost curve increases at an increasing rate and eventually hits a wall right there. That output level is sometimes called the capacity. That's the physical limit beyond which output cannot be increased. So, marginal cost curve. Marginal cost is the increment in total cost for a small change in output. I'm exaggerating in this diagram so you can see delta Q, change in output. So marginal cost is the slope of this line, okay? But when delta Q becomes small and smaller and smaller, eventually it becomes the slope of this curve at that point, okay? That's called marginal cost. So here's the definition. Total cost is sum of fixed cost and variable cost. Change in total cost is change in variable cost because fixed cost does not change. Change in total cost divided by change in Q is same as change in variable cost divided by change in Q, which is marginal cost, okay? Average cost is total cost divided by the output level. So it has two components. Fixed cost divided by Q is sometimes called average fixed cost. And variable cost divided by Q is also called average variable cost. Okay? So if you compile all these cost curves, these 4 cost curves, we can say the following. Average fixed cost curve is a rectangular hyperbola. It always goes down, never hits the horizontal axis. Okay, so mathematicians call it, this AFC approaches the horizontal axis asymptotically. It is always declining but never touches the horizontal axis. Okay, so AFC is negatively sloped everywhere. I mean literally everywhere. It is always negatively sloped. The remaining 3 curves are all U-shaped. They all look like this. Okay, not that. I forget about the, oh, this is not easy. Is something wrong with that. All these cost curves are U-shaped except the average fixed cost. Average cost, average variable cost, and marginal cost, they are all U-shaped. And lo and behold, marginal cost curve is going through the bottom point of AC and the bottom point of AVC. Okay, like that. It goes through this point and that point, and it is U-shaped. That is the general shape of marginal cost curve. Okay, so practice this diagram several times so that you can reproduce them yourselves without taking a look at this, without looking at this, okay? So we now consider inverse relationship between cost and marginal product curves. So total cost is the sum of fixed cost, R times K, rent times the amount of capital input, plus the cost of labor. Labor is the variable input here. So marginal cost is change in total cost divided by change in output. But since there is only one variable input, labor, change in total cost is W times change in labor, okay? But this term is simply marginal product of labor upside down. Marginal product of labor is change in Q divided by change in L, okay? So we now see wage rate is fixed. We now see there is an inverse relationship between MC and marginal product of labor. When marginal product of labor is rising, this ratio must be going down. When marginal product of labor is going down, marginal cost moves in the opposite direction. Okay? So we know the shape of marginal product of labor is better shaped like this. And that's the reason why marginal cost curve is U-shaped. Okay? There is an inverse relationship between marginal cost curve and marginal product of labor curve. Next, we observe a similar relationship between average variable cost and average product of labor. Why? Because average variable cost is variable cost divided by the output level, which is variable cost is simply the cost of labor, W times L, divided by Q. But L over Q is simply average product of labor upside down. So when average product of labor is going up, average variable cost is going down like that. When average product of labor is going down, average variable cost is going up. Okay, so again, there is an inverse relationship between average variable cost curve and average product of labor curve. Okay. Now, the relationship between average cost, we can deal with this one. Average cost, the transparency where the slides does not say enough, but remember, IFF is not a typo. It means if and only if. That means it is a necessary and sufficient condition for the other. If one holds, then the other holds also. If one does not hold, the other one does not hold either. Okay? So when average cost is falling because of the last output, if marginal cost is less than average cost, obviously average would decline. Okay? If marginal cost is higher than average, then average cost is rising. Okay? And this condition means average cost rises if and only if marginal cost is higher than average cost. Don't forget that. Okay? So this means AC reaches its minimum when they are equal. So it looks like this. Here is the relationship between marginal cost and average cost. And all of these three curves are U-shaped, and marginal cost goes through the bottom of AC and also the bottom of AVC. It goes down further, reaches its minimum and then go up, okay? And marginal cost and average cost never meet again. If you extend this further, they're gonna, and this further, they never meet, okay? Although in discrete case, one may have an anomaly, okay, where they seem to meet, but they do not meet in practice. Okay, so all these three cost curves are U-shaped. Marginal cost curve goes through the bottom or minimum point of average cost curve, and also the bottom point of average variable cost curve. Okay. I think I hit the limit. I think that's all I had to say. Go back to so this is the general shape of average cost curve. It is U-shaped, okay? And here, we just review this. Of course, these are all true, but that's not enough. We are saying if average cost is falling, that means like on the final exam, average score is falling because of one last guy was added to this class, that means the last person has a lower score than the average students in the class. So the reverse is also true. If AC is rising, it is because marginal cost is higher than average cost. This also holds. Okay, so when AC is at its minimum, these two are equal. So if they ever meet again, average cost is at a minimum, and it will have a flat slope, like here. Here it's the slope of this curve is 0. Here it's not positively sloped, it's not negatively sloped. Okay, so this does not, they are not equal, they don't meet one more time. No, just once. Solo una volta, just one time. Okay, marginal cost and average cost. Okay, when average cost is declining, average cost is declining, MC must be lower than average. Okay, here it shows approximately, it shows the correct relationship between average cost and marginal cost curve. Okay, they meet only once here, they don't meet again here on the left side. Okay, they never meet one another. Okay, so when output level equal to 100, MC is 20 and AC is 18. AC is 18 here. At output equal to 101, and MC is 20. So marginal cost is higher than average cost. MC is greater than AC, so AC must be rising. So the answer is rise above 18. If the marginal product of labor is rising at a certain level of output, marginal product of labor, remember, marginal cost is wage rate divided by marginal product of labor. If marginal product of labor is rising, that will be this portion. Okay, then because it is rising, this ratio is going down. Marginal cost is falling down like that. Okay, so the answer is falling. Marginal cost is falling at that level of output. In the table below, what is the marginal cost of 30th unit of output? Marginal product here is, this difference in output is 160 minus 120, that's 40 units. And change in output is 10 units, so that's 40 divided by 10. And then from 160 to 230, that difference is 70. Change in output was 10, so 47, marginal cost is rising from 4 to 7, so it is rising. So the answer is 7. Okay, we stop here. Any questions? You can unmute and ask questions if you like. Okay, then we will stop here.
Thank you.
Thank
You're
you.
welcome.
Thank you.
You're welcome. De nada.